Let me again tell you something about circular motion. See, for a particle to undergo circular motion, centripetal force is a must. But many of the students are of the opinion or feeling that mv square by r itself is the centripetal force. That's not the case. There is someone like tension in the string, friction, normal reaction, weight. See, I hope you agree that these are the forces which you have identified in various chapters. Magnetic field force, electrostatic force. So, one among these should be ready to provide the centripetal force, whom you can always equate to mv square by r. It's like F equal to ma. On the left hand side, you are supposed to write the force. On the right hand side, you are supposed to write mass into acceleration. And if it is circular motion, acceleration should be written as v square by r. So, identify the force and then equate it to mv square by r. See, let me take a very interesting example. Suppose I pass a statement that there is a car which is undergoing a circular motion on a smooth horizontal road, and I ask you whether the statement is true or false, right? So, what should be your answer? Again, listen to the question carefully. A car is undergoing a circular motion on a smooth horizontal floor. Now, here if you look at the forces which are acting on the car, one is the weight of the car which is acting on the road perpendicular to the road and vertically downwards. Second is the normal reaction of the road which is acting vertically upwards. And because circular motion is going on, the center of the circle should be somewhere on the road. So, neither normal reaction can be towards the center nor mg can be towards the center. So, none of them can provide the necessary centripetal force for the car to undergo circular motion. And road being smooth, there is no friction unfortunately. So, the statement is wrong. A car undergoing a circular motion on a smooth horizontal road is wrong. But if the road were to be rough, then certainly friction would be acting on the road, and that can provide you the necessary centripetal force. So, now if you read the question, I think you will understand that the road is rough there, and let us see how to solve this. A person is driving a vehicle at 5 meters per second on a horizontal road. See, the road is horizontal, it is not banked, but it is curved and has got a radius of 5 meters. The coefficient of friction between the road and the vehicle is 0.1. You can say road and the tires of the vehicle is 0.1. Will he slip or not, or if at all he slips, at what speed is he going to slip is the question. Options given are also connected with the slipping. Slips if the speed v square is more than 5, slips if v square is less than 5, again slips if v square is more than 5, or does not slip if v square is more than 10. Okay, so as I suggested, what we will do is, we will just make the free body diagram of the car. See, this is the road, this is the car, weight of the car is acting downwards, I have written it as mg, normal reaction is acting upwards, and if the center of the circle on the road is somewhere here, you can show the friction to be acting towards the center. See, because friction is the only force, we are at the mercy of the friction. Neither normal reaction is ready nor mg is ready to provide the centripetal force, because both of them are not directed towards the center. It is only friction which can provide you the necessary centripetal force, and so you cannot say friction should be acting away, it should be directed towards the center. So, I will write F equal to mv square by r. See, I was supposed to write F equal to ma, but because circular motion is there, I have written mv square by r. But this friction being static, it cannot be more than mu into n, because the maximum value that the static friction can take is mu into n. Therefore, you can write mv square by r should be less than mu into n, and n is mg. So, m gets cancelled. So, v square should be less than mu r g. Look at the value of mu, it is given to be 0.1, r is given to be 5, right, and g is given to be say 10. G is not given, but we can always use the value of g as 10. So, mu into g, that is 0.1 into 10 would make it 1, and into 5. So, v square should be less than 5 is the correct answer. As long as you keep the speed of your car or your vehicle less than, or square of the speed of your car less than 5, so long there is absolutely no risk of slipping, because your demand will be met by the friction. But in the case you increase your speed or square of the speed more than 5, then friction will be unable to provide you the necessary centripetal force, and then you will start slipping. So, the correct answer is it will not slip if V square is less than 5. So, B is the correct answer. Banking. But unfortunately, as the circular motion is being exhibited by airplane, it's not like banking of roads. See, if it were to be a vehicle, I think we would have banked the roads for the vehicle's comfort, right? But here it's an airplane, therefore it has banked its own wings, right? Okay, but so let me try to explain you about why is banking done basically. If you want a particle to undergo circular motion on a horizontal road, or if you want your vehicle to undergo circular motion on a horizontal road, it is at the mercy of friction. Normal reaction is vertically upwards, weight is vertically downwards. Therefore, none of them are ready to provide the necessary centripetal force. Hence, it is only the friction which can provide the necessary centripetal force. But unfortunately, when you make use of friction to undergo circular motion, there is a lot of wear and tear of the tires. Therefore, roads are banked, and the advantage is when you bank the roads, you can always make use of the component of the normal reaction of the road to provide you the necessary centripetal force, and you can avoid friction. Therefore, that is the advantage of banking of the roads. But let me read the problem now, and as I said, it is an airplane and therefore it has banked its wings. An airplane executes a horizontal loop at a speed of 720 kilometers per hour with its wing banked at 45 degree. What is the radius of the loop? G is given to be 10 meter per second square. Now, let me draw the banked wings of the aircraft like an inclined plane, inclined at an angle of 45 degree with the horizontal. See, this is 45 degree and say this is the aircraft, these are its wings, weight of the aircraft is acting vertically downwards, you can call it as mg, and this is a sort of normal reaction on the aircraft, and you can call that normal reaction to be the buoyant force, because it is not in contact with any hard surface there, so you cannot call it to be the normal reaction. Do not forget that the aircraft is in the air and it will be the buoyant force which will be acting on the aircraft. So, I have called it as B. This is just the extension of the vertical line, this is the extension of B, this angle is 45, so this angle will also be 45. This component of B, which is B cos 45, will take care of the weight of the aircraft, and B sin 45, which is in this direction, will provide the necessary centripetal force for the banked aircraft to undergo circular motion. So, now I will write B sin 45 equal to mv square by r, and B cos 45 taking care of the weight of the aircraft. So, if you divide these two, you get tan 45 equal to v square by r g. R will be v square by g. That will give you the radius. Now, what is the speed of the aircraft which he has given? It is 720 kilometers per hour, and 720 kilometers per hour will lead to 200 meters per second if you convert it. So, 200 square divided by 10, that is 4 into 10 to the power of 4 divided by 10, which makes it 4 into 10 raised to 3, and 4 into 10 raised to 3 meters is nothing but 4 kilometers. Therefore, the correct answer is A, and it is 4 kilometers. See, this is a problem on pseudo force, as I was mentioning earlier. This is also a very important part of Newton's laws of motion. When should you use pseudo force? What exactly is the magnitude of the pseudo force? What should be its direction? Let me share a few things with you. See, pseudo force has to be used only when you choose an accelerating frame of reference as the reference frame for solving the problem. Many a times it is not compulsory. I think a choice of the frame of reference always comes by a comfort, in the sense, if the problem happens to be very easy in solving it from a frame of reference which is accelerating, you can go ahead, use the pseudo force and solve the problem. But please remember that pseudo force has to be used only when the frame you have chosen to solve the problem is accelerating. So, that is non-inertial frame. Okay. The next question is, what should be the magnitude of the pseudo force? It is mass of the body which is being analyzed multiplied by the acceleration of the frame of reference which you have chosen, and the direction will be always 180 degree opposite to the direction of acceleration of your frame of reference. Fine? Okay, but this is only when you want to solve the problem in the frame of reference which is non-inertial. Now, let us see what is the speciality of this particular problem. A block of mass m is in contact with the cart C, and friction between the cart and the block is mu. Acceleration of the cart is a, which is to be found so that the block is prevented from falling down. Fine? I hope you agree with the situation. See, why should the block fall down? The block is connected to the vertical wall of the cart and the weight of the block is acting vertically downwards, right? But the normal reaction of the cart on the block will be horizontal, and normal reaction cannot take care of the weight which is in the vertical direction. So, now it is only the friction between the block and the cart which can take care of the weight of the block, right. So, what we will do for the equilibrium of the block in the vertical direction is write F equal to mg. But remember, this friction is static because you want the block to be at rest with respect to the cart, and static friction has got some upper limit. There is a limiting value for that. It can take any value only till the limiting value is reached. Beyond that, it just raises its hands and it cannot cooperate. So, what I will do is, I will insist that this mg, which is the value that the friction should support, should be less than or equal to the maximum value of the static friction given by the formula mu into n. Mu is given, mu is say mu only. Now, n, as I said, is in the horizontal direction. And what does n do to the block? N favors the block to accelerate with the same acceleration as that of the cart. That is not given, but I hope you agree with that, because if the block has to remain in contact with the cart, with whatever acceleration is the cart moving, the block should continue to move with the same acceleration. Therefore, if you write n equal to ma and substitute here, you get mg should be less than or equal to mu ma, and that makes a greater than or equal to g by mu, and our answer is the third one. A should be greater than or equal to g mu a, that is C option.